All right, welcome to the Explainer. Today, we're going to dive into some absolutely incredible engineering, the microscopic stuff that powers your body's entire circulatory system. I'm talking about a network that's, way more complex and efficient than any highway system we could ever build.
So let's just start with this one question, right? It's something we totally take for granted, but think about it. The sheer logistics of keeping billions of your cells fed and happy second by second, it's a huge task. And the answer, of course, is all in our blood vessels.
So for your average guy, this is how much blood is just constantly on the move inside you. It's like this river of life, and it's on a non-stop mission to supply literally every single corner of your body with everything it needs.
And it all works because of this massive biological highway system. So, you know what? Let's actually follow the journey. Let's take a ride through this network, from the huge superhighways leaving the heart all the way down to the tiny little back roads where all the real action happens. Okay, Section 1, your body's superhighway. So first things first, let's map out the main roads. The whole system is really built on just three major types of vessels. You've got your arteries, your veins, and then the tiny capillaries that connect them. Now, the two biggest players here are arteries and veins. A great way to think about it is that arteries are like the delivery trucks, right? They're heading away from the central warehouse, your heart, and they're carrying all the fresh supplies. Veins, on the other hand, are the return route. They're bringing all the used up stuff and waste back. Because they have totally different jobs, as we're about to see, they're built in completely different ways. All right, Section 2, the high-pressure expressway. This is where our journey really kicks off, with this powerful push. Blood gets shot out of the heart with this incredible force, right into the high-pressure, high-speed system of arteries. It's the expressway leaving the city for sure. So yeah, the key thing to remember here is just their direction and what they're carrying. Arteries take that precious, oxygen-rich blood away from the heart and out to the tissues that are just desperate for it. Now, there is one exception, the pulmonary artery, but for the most part, that's their job. And you can really see the whole hierarchy of this road network right here. The journey kicks off in these huge, elastic arteries like the aorta. Then it branches out into these medium-sized muscular arteries that go to different parts of the body. And finally, it all funnels down into these teeny tiny arterioles, which are basically the local streets. So, you might be wondering, how in the world do these vessels handle all that intense pressure coming from the heart? Well, the secret is all in their walls. See, arteries have this really thick and powerful middle layer. It's called the tunica media, and it's just packed with smooth muscle and elastic fibers. This lets it expand and then snap back with every single heartbeat. Okay, on to part 3, the neighborhood delivery route. So after that trip down the highways, our blood has finally arrived at its destination, this huge microscopic network of capillaries. And this is where the real work happens. Yeah, this is it. This is the whole point of the entire journey. All that high-pressure pumping, all that traveling, it was all for this one moment. It's this quiet, super efficient exchange where oxygen and nutrients finally get to leave the blood and enter the cells. And at the same time, all the waste products get picked up for the ride back. And it turns out, capillaries aren't a one-size-fits-all kind of deal. They're actually specialized for wherever they are in the body. So you've got continuous capillaries in your muscles, and they're really selective about what gets through. Then there are fenestrated ones, which have these little pores for more exchange. And then you get to sinusoidal capillaries, like in the liver, which have huge gaps that let even proteins and whole cells pass through. It's like custom engineering for every single neighborhood. Okay, so how does your body decide which neighborhoods get more blood flow and which get less? Well, at the entrance to all these capillary beds, there are these tiny little rings of muscle. They're called precapillary sphincters. And you can just think of them like little traffic cops, opening and closing to control exactly where the blood goes. And here's a perfect example of how that works. Let's say you start exercising, right? You go for a run. Those little sphincters in your leg muscles, they relax, and that just floods your muscles with all the extra oxygen they're screaming for. At the same time, the sphincters in places that aren't as important right then, like your digestive system, they actually tighten up. It's just a brilliant, brilliant traffic management system. All right, Section 4, the low-pressure return trip. So the delivery is done, the blood dropped off all the good stuff, the oxygen, and now it's loaded up with carbon dioxide and other waste. It's time to head back to the heart, but this journey is on a totally different kind of road system, the low-pressure veins. And this brings up a huge engineering problem for the return trip, right? I mean, that powerful push from the heart, it's gone.
The pressure is super low, so how on earth does blood get from your toes all the way back up to your chest, fighting against gravity the whole time?
Well, it turns out the body has this fantastic two-part solution, a couple of secret weapons to solve this exact problem. It's this awesome combination of smart design and just borrowing a little help from other systems in the body.
So, secret weapon number 1. Veins are lined with these amazing one-way valves. They're like little gates that let blood flow up toward the heart, but they'll snap shut instantly if gravity tries to pull it back down. And number 2, as we just walk around and move, our own muscles contract and literally squeeze the veins, physically pushing the blood upward. It's this awesome system called the muscle pump. Just brilliant.
And you can see the difference right here in this comparison. It makes perfect sense, right? Because veins don't have to deal with all that high pressure. Their walls are just so much thinner and way less muscular than artery walls. It's a perfect case of form following function. Okay, so the return trip actually starts in these tiny little vessels called post-capillary venules. And they have this one really cool feature. They are super leaky. And this is absolutely crucial for your immune system. Think about it. You get a mosquito bite, right? That swelling you see? That's happening right here. This is where fluid and white blood cells leak out into the tissue to go fight whatever's going on. And that brings us to our final section, number 5, an incredible endless loop. Just like that, the blood, now without its oxygen, arrives back at the heart. It gets sent over to the lungs for a quick refill, and then the whole incredible, life-sustaining journey just starts all over again.
So, what's the big takeaway here?
I think it's that this is so much more than just a bunch of plumbing. It's a dynamic, perfectly designed system where the structure of every single part is directly tied to what it needs to do. You've got these thick, tough arteries for high pressure, these super thin capillaries for exchange, and these really clever veins for that long, low-pressure trip back home.
And just think about this for a second. This whole journey, from your heart down to your toes and all the way back again, takes about a minute. And it happens every single minute of your entire life. It really makes you wonder, doesn't it? I mean, if the engineering is this brilliant just to move your blood around, what other incredible silent systems are working away inside you right now just to keep you going?